Hello folks, I'm Mr. Pinola, and the hot plate in front of me is really hot. I'm not sure if you can see this, but its temperature right now is 550 degrees Celsius. Now you could do a conversion and figure out what that is in Fahrenheit, but rest assured, this is an extremely high temperature, and if I put my hand on here, it would really hurt. I'm going to place this beaker filled with about 150 milliliters of water on top of the hot plate. What is going to happen to the water? Well, if you've watched some of our previous videos, then you know that the molecules within the water are going to start vibrating a little bit faster. And since those molecules in the water are vibrating a little faster, two things will happen as a result. First off, the water will expand slightly. However, it's going to be so slight that we will barely notice it with our eyes. The second thing, though, is perhaps more noticeable, and that is that because the molecules are going to vibrate faster, the temperature of the water will go up. We're going to take a look today at the factors that affect how quickly or by how much the temperature of this water changes. Before we do that, do you know what this symbol is? No, it's not just a simple triangle. It's actually a Greek letter. This is the Greek letter delta. And delta, as you may have learned about in math class, means change. Scientists will typically put a delta before a value to show that the value is changing. So if I write delta t, what do you think that means? Excuse me, I'm going to actually make sure that my value is a delta capital T, not a lowercase t. What do you think delta capital T means? It actually means the change in temperature, because a capital T will represent temperature. So a change in the temperature is represented by delta T. And that's what we're going to be exploring today with our hot plates. We're going to look at how the temperature of the water, capital T, changes. So let's get down to business. You may have noticed that the hot plates seem to have multiplied. There's now two in front of me. But the one on this side is not quite as hot. This one is at 550 degrees Celsius. This one to my right is only at 225 degrees Celsius. It's half the temperature. Now, when I do what I did before and I put a beaker on top of the hot plate, we know that heat is going to flow from the hot plate to the water. Do you remember why? Well, as we talked about in a previous video, heat always flows from high to low temperature. The hot plate is a high temperature, and the beaker with the water is at a low temperature. So whether I place the beaker on this really hot plate or this slightly cooler one, the hot plate is still at a higher temperature than the water. So in both cases, heat will flow from the hot plate into the water. And that's because heat always flows from high to low temperature. We are using heat to change the temperature of the water in the beaker. But how does the amount of heat that I use affect how much the temperature of the water changes by? Well, here I have two containers that each have 150 milliliters of water. I'm going to place them on top of these two hot plates, this one at 550 degrees Celsius and this one at 250 degrees Celsius. In both cases, heat is transferring from the hot plate to the water. However, this beaker that's on the hot plate that's at 550 degrees Celsius is receiving twice the amount of heat. So, what will twice the amount of heat do to the temperature? Well, we're going to put a thermometer in each of our beakers. And we'll let them sit for a couple minutes, and we'll take the reading on the temperature to make a discovery. Time's up. Let's check out the temperature of the water in each beaker. Now, before I do that, I should tell you, or I should have told you before, that the initial temperature of the water in each beaker was 23 degrees Celsius. That's because they were both at room temperature before I placed them on the hot plate. Let's take a look first at the temperature of the water that's on the hot plate that is slightly weaker. It's the one receiving less heat. It's at a temperature of 36 degrees Celsius. However, the other beaker is at a temperature of 77 degrees Celsius. They both started at 23 degrees Celsius. This one went up to 36. This one went up to 77. Let's go back to our board and take a look. So we just discovered one factor that is going to affect delta T, or the change in temperature. And that factor is heat. If more heat is delivered, then the object will change its temperature by more. We always find change by subtracting the initial amount from the final amount. So one beaker went from 23 degrees Celsius to 77 degrees Celsius. That means that the beaker changed its temperature by 54 degrees Celsius. The other beaker went from 23 degrees Celsius to 36. It changed its temperature by only 13 degrees Celsius. So clearly, the one that was exposed to more heat changed its temperature by a bigger amount. So one factor that affects the change in temperature is heat. And that's because more heat means a bigger change in temperature. So we saw that the amount of heat delivered is one factor that could affect how much the temperature of an object changes by. But let's take a look at another factor. And that factor is going to be mass. I have twice as much water in this beaker as I do in this beaker. That means there is twice as much mass or matter or water molecules in this beaker. I'm going to put them on the same hot plate and once again wait a couple minutes and see which one changes its temperature by more. And again, the reason I'm putting them on the same hot plate is so that they get the same amount of heat. Now we are keeping heat constant and we are changing the mass to see what happens if we have more mass versus less mass. Let's put them on the hot plate and let's set up our thermometers once again. We'll check back in a couple minutes. Time's up once again. Let's check in on our beakers and see what their temperatures are at now. First, I'll look at the beaker that had less water in it. Its temperature is 72 degrees Celsius. The beaker with more water, its temperature is 44 degrees Celsius. So, the beaker with less water went from 23 degrees Celsius to 72 degrees Celsius. And the beaker with more water went from 23 degrees Celsius to 44 degrees Celsius. Let's go back to our whiteboard, calculate the difference, and draw another conclusion. So the second factor that clearly affects delta T, or the change in temperature of a substance, is the mass. And we can very clearly see that if an object has less mass, it will have a bigger change in temperature. And that's based on, once again, scientific data. So one of our beakers went from 23 degrees Celsius to 72 degrees Celsius. That's a pretty big change. It went up by 49 degrees Celsius. Our other beaker, well, it went from 23 degrees Celsius, but only up to 44 degrees Celsius. That's a smaller change by only 21 degrees Celsius. Notice I'm getting some quantitative data here. I'm using numbers to back up my conclusion. We can see that the beaker that had less mass changed its temperature by a greater amount. And that allows me to conclude that less mass will result in a bigger change in temperature, provided that all other factors stay the same. So now let's wrap up by taking a look at one last factor that may affect how much the temperature of the substance changes by. We already saw that adding more heat will result in a bigger temperature change, and having less mass will result in a bigger temperature change. But what if the substance wasn't water? Here I have a container of water, but I also have a container of vegetable oil. I have the same amount in each beaker, and I'm going to put them on the same hot plate. So they will receive roughly the same heat, and I've adjusted it slightly so that they have roughly the same mass. However, the substance is different. Let's put them both on a hot plate. Take our thermometers once again, put them inside. And for a third and final time, we're going to wait a couple minutes, and we're going to see what the temperatures are. Since all other factors are the same, will the type of liquid affect how quickly or by how much the temperature changes? Let's find out in a moment. For a third and final time, time's up. Let's take a look at the temperature of the substances in our beakers. First, we'll check in on the water. The water is currently at a temperature of 48 degrees Celsius. How about the vegetable oil? Wow, it's at a temperature of 73 degrees Celsius. 48 degrees Celsius for the water, 73 degrees Celsius for the vegetable oil. Clearly, the substance made a difference. Both beakers were exposed to the same amount of heat, and there's basically the same mass in each beaker. But the vegetable oil increased its temperature by dramatically more. Let's go to the board and draw conclusions. So there is clearly a third factor that affects how much the temperature of something changes by. And clearly that third factor is the substance type. Based on what substance we're dealing with, it might change its temperature by more or less. And that's because for the oil, our temperature went from 23 degrees Celsius all the way up to 73 degrees Celsius. That was a pretty big change. In fact, it was an increase of 50 degrees Celsius. The water, however, didn't change its temperature quite as dramatically. It only went up to about 48 degrees Celsius. So our water increased its temperature by half, only 25 degrees Celsius. The numbers don't lie. Clearly, the substance type makes a difference. And oil, in this case, is able to change its temperature a lot more quickly and a lot more dramatically than water. But you might be wondering, how do we quantify or give a number to substance type? Well, rather than saying substance type, we give this a name. We say that it is the specific heat capacity of a substance. And oil has a lower specific heat capacity than water. It's a property that oil has, just kind of like density or color. Certain substances have different properties, and every substance, whether it's a solid or a liquid or a gas, has a specific heat capacity. Oil has a lower specific heat capacity than water, which means that it's less stubborn. It is more likely to change its temperature. Water is quite stubborn. It won't change its temperature very easily. But oil, because of its low specific heat capacity, will change its temperature very fast. So we can conclude that lower specific heat capacity, which is different from heat. Specific heat capacity is a property of a substance, means that we will have a bigger change in temperature. So make sure you understand what specific heat capacity is. It is a property that a substance has. that tells how quickly or how much it will change its temperature by. And objects that have lower specific heat capacities change their temperatures by bigger amounts. Just like oil changed its temperature really readily, but water did not. Oil had a lower specific heat capacity, and in fact, oil always has a lower specific heat capacity than water. So to wrap up, 3 factors affect how the temperature of a substance changes. The first factor is the amount of heat that it's exposed to. The second factor is the mass of a substance. And the third factor is the specific heat capacity of a substance. So if you want to change the temperature of something by a lot, you should use a lot of heat energy, transfer a lot of heat energy to the substance, maybe put it on a really hot plate or outside on a really warm day. Use very little mass. It's much easier to heat up a puddle of water than an entire ocean of water. And lastly, check the specific heat capacity. It's much easier to heat up a substance like oil than it is to heat up water. Next time that we're together, we're going to talk a little bit about how to use calculations to show this. I'm going to give you a little bit of a preview of that. Scientists give symbols to these 3 things. They give the symbol Q to heat. They give the symbol M, or specifically a lowercase m, to mass. And they give the symbol C, a lowercase c, to specific heat capacity because of the C in the word capacity. So if we think about it in terms of symbols, the 3 factors that affect the change in temperature of something are Q, which is heat, lowercase m, which is mass, and C, which is specific heat capacity. We'll save the math for next time, but hopefully you understand the concept after seeing our demonstrations today. Thanks for watching.